locating percentiles under the normal curve. For this sample exercise, we will find the 87th percentile of the normal curve. And we have to take note that by definition of the 87th percentile means locating an area before or below the point. And we want to know what the z value is at this point. So the first step for us is to illustrate the normal curve. So, and here we have to apply the concept of a percentile. So let me just add the image of the normal curve. So as I was saying, we'll apply the concept of percentile by arranging the values in the normal curve in ascending order. So the first percentile is going to be at the leftmost part of the normal curve. So here we have the first percentile, and the 50th percentile will corresponds to the mean or the center. So here, and our 99th percentile will be at the rightmost part of the normal curve. So this is now the working normal curve that we will have for the sample exercise. And we have to remember that the 87th percentile is going to be somewhere here. Okay, somewhere there. Now, next step is for us to express the percentile into percent and then as probability. So let me just move it here. So we have this. So expressing it into as percent is we have 87%, or as probability it's 0.8700. Okay, then the next step is for us to expand or split the probability into two. But we have to take note that the characteristics of each should reflect the areas that can be found in the z table. Okay, so to expand this, to expand 0.8700, so this is going to be 0.8700 is equal to 0.500 and 0 plus 0.3700. Okay, we have to do this so that we can locate the z-score or z-value that corresponds to our 87th percentile, which is found above the mean, as you can see on the first step. So the fourth step here is for us to locate the area or areas in the normal curve. So this is going to be our fourth step. Let me just put this up. So sorry, let me move it up, and this one. Okay, so this is going to be our, and we have to add another, the normal curve again. I'll be able to show it to you clearly. So here, let me just move this a little here and move this to the right. Okay, so from here, remember this is the first percentile, and we have the 50th percentile here, and we have the 99th percentile, and we have two areas. 0.5000 is one, this, and 0.3700 here. So the first area corresponds to the area that you see entirely the left side of the entire area, the left side of the mean. So that's basically our 0.5000. Okay, while our 0.3700 is going to be from the right, from the mean to its right. Okay, so here, but we're not so sure yet. We're not sure yet what is the z-score that would represent the missing area, 0.3700. Now it leads us to the fifth step, which is to determine the z-score that corresponds to the area that we're looking for. So this is the fifth step. So let me just move this here. So this is now our fifth step. Determine the z-score that corresponds to the area that we're looking for. So the rule of thumb is to find the area in the z-table closest to the area that we are looking for. So we need the z-table here to assist us locate the area. So remember, the missing area is 0.3700. So that's our missing area. The missing area is 0.3700. This is our missing area. We do not know this yet. So question mark. Then this, we have to move it to the right. Move it here to the right. And I'm going to make this a little bigger. Okay. So too much. So here we have to look for 0.3700 in our z-table. Okay, so in the z-table, the closest area to 0.3700 is 0.3686, which is equal to the z-score 1.12 or 1.12. So this, let me just, the closest is this area. Okay, 0.3686. Okay, that area. Let me just, okay, and here, this is now the z-score. This is now the z-score that represents the area. So the z-score that represents the area 0.3700 is 1.12. Okay, so 0.3700, or the 87th percentile. 87th percentile. Okay, and this is now our final answer. This is now our final answer. Okay, that's it. Thank you.